Hey everyone, welcome back to another video on the channel. In this video, we are going to discuss about strong numbers. In the previous videos, we have already discussed about other types of numbers such as palindrome number, Armstrong number in full details. If you haven't watched those videos yet, I will be leaving the link in the description. You can definitely check them out. So let's start the video by discussing what is a strong number. Strong number is basically a type of number where the number is same as the sum of the factorial of their digits. For example, here 145 is equal to the sum of its uh, factorials of its digits. So this is the logical explanation of what is a strong number. Now, how can we explain or programmatically or algorithmically describe what is a strong number? So, for that, we have to follow some steps. First of all, we have to extract the digits by modulo 10 operation. Then we have to calculate the factorial of a digit, and we will discuss later how to calculate the factorial. We will go into the details later while we are coding out the problem. Then we have to sum the factorial of that digit with the previous sum that we have got in the previous iteration. And in the last step, we have to check if the sum that we have obtained is same as the number or not. If it is same, then it is a strong number. If it is not, it is not a strong number. So now let's go into the GFG code editor and code out the problem. Here we have the same example over here. 145 is the given number, and if the given number is a strong number, we have to return 1, otherwise we have to return 0. So let's start the problem. So first of all, we need a sum variable, so we initialize the sum variable with 0. Now we have to extract the digits of the number. While n not is equal to 0, we have to extract the last digit. Int ld. Ld stands for last digit. We have to extract the last digit over here by modulo 10 operation. And after we extract the last digit, we have to do the factorial operation. And then how can we do the factorial operation? We have to initialize a factorial variable here. And then we have to run a for loop from the number that is our last digit, and then till where we have to run it? We have to run it till I greater than 1. Then I minus minus. Then we have to multiply fact is equal to fact into I. So this is basically going to be our factorial. For example, let's say our last digit is 5. So we initialize the factorial over here as 1, and then we run a for loop from 5 to 1. 1 is not included over here, so our loop will run from 5 to 2, and at each step the I value will be multiplied with the factorial value. In the first iteration, it will be 5. Fact is initialized as 1. It will be 1 into 5. Then in the second iteration, it will be 5 into 4, then 20 into 3, then 60 into 2. Likewise, it will go on. So in this way, we can calculate the factorial of a number. Now that we have got our factorial, we will add up the factorial within our sum variable. Then at last, we have to check if our sum is equal to n, then we have to return 1. Otherwise, we have to return 0. Now, now if you notice, we are sorry, I forgot over here to divide the number by 10, because at every step we have to divide the number by 10 so that we can extract the next digit in the next iteration. And as we are doing operation with the input number, given input number, so our number will not be the same as it was given in the first place. So in order to do this comparison, we have to store the number in a temporary variable. So here instead of n, I will have to write temp because our original number is equal to 0 after all these operations. Now we have to hit the compile button and check if our output is correct. As you can see, our output is matched, and then we have to click the submit button and check if the test cases have been passed. As you can see, all the test cases have been passed successfully. And one more thing I would like to say over here that this is not the most optimal approach of this problem because we are using a for loop inside a while loop. So both the loops will increase the time complexity of the problem. Instead, what we can do is that we can use another function for the factorial and then use recursion to get the factorial of a number. But again, if I use that, then the problem will become too much complex to explain. So that's why I'm keeping it simple because our main goal is to understand the logic of the strong number. But when I move into the factorial of the number, then I will explain both the approach using recursion and without using recursion. In that factorial chapter, we will discuss in details. So thank you everyone. I hope you watched and liked this video. And if you have any doubts, please let me know in the comments. Until then, keep learning. Thank you.